Okay, so I just want to take a couple minutes to discuss the shape of a function based off of what its first derivative and ultimately second derivative values are. What we go through here is actually going to include a healthy amount of terminology. We don't want to get too beat up over the terminology, frankly, because they're just going to be words to describe things that are relatively easy to describe mathematically. So as we go through, like as I introduce new terms, it'll be something to get used to for sure, but fortunately you actually see these ideas repeated quite a bit between now and your test in a couple weeks, and that's going to give you a chance to familiarize yourselves with these ideas and then, ultimately get more comfortable with what these words mean. So the first derivative, as you know, is a measure of slope, and in effect this is telling you where the original function is increasing or decreasing. Because if you think about this, when the first derivative is positive, when the slope is positive, the function is sort of shaped like this. Now, does it mean that the function is going straight up like a line? No, of course it doesn't, but it just means that the function is going uphill, and that's enough to say that the function values are increasing. The function values are increasing when the function is going uphill, when the first derivative is positive, when your slopes are positive. The function would be decreasing when the function is going downhill, when the slopes are negative, when your first derivative is negative. I could give you any function, if you computed its derivative and determined where the derivative was positive and where the derivative is negative, you would have a notion of where the function was increasing or where the function was decreasing. And actually then, if you take that information and take one step back, think about this. As you're moving from left to right, what if the slopes change from positive to negative? What's that going to look like? If the slopes go from positive to negative, you must have hit a peak. If you go from uphill to downhill, there was a peak in between. We call that a local maximum. Let me write this in blue here. Local maximum. And correspondingly, when the first derivative changes from negative to positive, you know what that looks like. If you're going downhill and then uphill, if your slopes are negative and then positive, you must have bottomed out at a local minimum. Cool. Okay, so we've got this notion of first derivative. What the first derivative means, it's a measure of slope. It's a measure of where your original function is increasing or decreasing. Okay, now let's talk about the second derivative. The second derivative is the derivative of the derivative. So whereas the first derivative tells you where your original function is increasing or decreasing, the second derivative tells you where your derivative is increasing or decreasing. And then you say, man, what does that possibly look like? Here, let me show you this picture. So my claim is that this shape, essentially the shape of a smile, is the shape of a function where the derivatives are increasing, where the second derivative is positive. Because think about this. Think about the slopes along this function. The slope initially is very negative, and then less so negative, then even less so negative. It actually becomes 0 at the bottom, and then transitions to be positive, and even more positive, and even more positive. So when you look at the slopes along the way, the slopes go from very negative to less negative to 0 to positive to even more positive. The slopes are going from negative things to positive things. That means that the slopes are increasing. And if the slopes are increasing, the derivative function is increasing, and the second derivative then must be positive. So when the second derivative is positive, we take this smile shape. Now, sometimes, frankly, I'm going to refer to when the second derivative is positive, the function is smiling, but let's give it a more technical word than smiling. When the second derivative is positive, we say that it is concave up. So concave up refers to a function that takes the shape of a smile. And in fact, second derivative, the word to describe the characteristic that it captures is concavity, whereas first derivative captures the characteristic of slope, uphill or downhill. Second derivative captures the nature of concavity. Second derivative positive, smiling, concave up. And second derivative negative, this is going to be the opposite, a frown. This is going to be concave down. sort of a clever, well, clever, I don't know if it's too strong a word, but a nice way to remember this is when the function takes the shape of a frown, the function is concave down. The corresponding notion concave up when the function is smiling. And now, second derivative negative, concave down. By the way, this actually works psychologically when you think about positivity and negativity, with like a frown being a negatively associated thing psychologically and a smile being a positively associated thing psychologically. So that's sort of useful. But okay, now let's verify the fact that indeed a frown, concave down, refers to when the second derivative is negative, when the derivative function would be decreasing. Take a look at the derivatives here along this function. As you move left to right, the derivatives start out very positive, and then become less positive, and then become 0, and then become negative, and then become very negative. So if you look at the change in the derivatives, the change in the slopes go from very positive to very negative. The slopes are decreasing. And if the slopes are decreasing, the derivative function is decreasing. If the derivative function is decreasing, the second derivative is negative. Ooh, it's a mouthful. But at the end of the day, here's what we can walk away with. When you test the second derivative to determine if the second derivative is positive or negative, a positive second derivative is a smiling function, and a negative second derivative is a frowning function. A concave down function is a frown, and a concave up function is a smile. And then if you think for a second, it's like, okay, well, whenever we talked about first derivative, when first derivatives change from positive to negative or negative to positive, we had this nature that we put words to describe what was happening at that point. And we called points where the function was going from increasing to decreasing a local maximum, or decreasing to increasing a local minimum. So here's the question. What do we call a function when, oops, I should have a second derivative here. What do we call a function when its second derivative changes from positive to negative? What do we call it when a function goes from concave up to concave down? We have a word for this as well. We call it an inflection point. An inflection point refers to a point where the second derivative goes from positive to negative, where the function goes from concave up to concave down. What about when your second derivative changes from negative to positive? When your second derivative, when you're changed from negative to positive, when you go from concave down to concave up nature on your function, we also call this an inflection point. So this is actually quite nice, because when it comes to second derivative, which is a little bit more complicated to think about, we only have one word here to describe both of these things, which is to say, anytime your function changes from concave up to concave down, or concave down to concave up, you have an inflection point. Which is nice, because you don't have to think as hard as whenever you have a local min or a local max. But the nice thing about local mins and local maxes, they're sort of easier to see with respect to the what the first derivative describes. But the long story short, first derivative describes slope, positive slope uphill, negative slope downhill. Second derivative describes concavity, positive second derivative smiling, negative second derivative frowning.